Okay, so in our previous video, we created an animal class hierarchy where we have animals, an animal class, I should say, a base class, and then we have two derived classes, dog and cat, both of which extend animal, and the cat doesn't do a whole lot of effort to change things other than essentially just changing what that default name is. And then we created some animal pointers, some dog and cat objects as well. So what I'd like to do now is first start off with a demonstration of what happens when we reference dogs or cats with an animal pointer. So I'm just going to call this AD pointer. Down here, I'm going to copy this code, except I'm going to make this an animal pointer. But it'll be an animal pointer to a dog object. So AD pointer is equal to the address of D. And we'll call speak, move, and eat. Okay, so that's really the fundamental change, the only change we've actually made to this existing class. So let's compile it and run, except that I have a bug. That should be capitalized. And when I run this, notice the difference. So with my animal pointer to the dog object, notice the animal methods always got called. This is definitely a dog object. Its name is Spot, right? It's pointing to this object right here, but we're only calling the animal methods. And if you're coming from Java, that might seem a little confusing to you because in Java, what would happen is we would call the dog objects. Well, in C++, the way the method that gets called gets determined is a little different, or I should say it's a lot different from Java. If we want to make our method virtual, and we'll make move virtual for now, and we'll come back and discuss what that means in a moment. So we compile, we run, and now notice move was virtual, and now that method for that virtual function gets the dog version called, whereas the non-virtual methods get the base class method called. So I'll put a comment here to summarize what's going on with a virtual method. So with a virtual method, it can be overridden by the child class, but the key to keep in mind is that the type of the object being pointed to determines the method that gets called. And that's different from a non-virtual method, and I'll put a comment in for that as well. And with a non-virtual method, the method can be overridden by the child class, but the type of the pointer determines the method that gets called. So with a non-virtual method, if I use a base class pointer, the base class method gets called. If I use the derived class pointer, the derived class method gets called. But with a virtual method, the derived class method always gets called. And we'll see an example of one particular use case where that actually might be helpful later. One thing that we want to do now is speak is overriding an existing function. So I can put the keyword override in here, and that tells the compiler that we're expecting this to override, except that it's move that we overrode. Before we go on though, I want to point out this error. Notice I put it on speak first, and it said it didn't override that. And the reason is speak is non-virtual, and override indicates that you're overriding a virtual method. If you're only overriding a non-virtual method, well, that method is still accessible. And so you're not really overriding it as you're providing a different copy with a different way to get access to calling that method. Let's go ahead and override or create a new method called fetch. And that's not going to override anything because the dog class fetches, but the other animal classes don't. So here's our fetch method. So now whenever we use our dog method, let's add the call to fetch. So one interesting case here is let's just try it here and see what happens. So let's compile this, and you'll see that we get an error. First off, speak was marked as override. Looks like it must not have saved. That is weird, because it did have this change on this line here where we say animal pointer fetch. Now this is pointing to a dog object. The dog knows how to fetch, but the animal class doesn't have a member named fetch. So if we're treating the dog like an animal, we're pointing to it with an animal pointer. That animal pointer doesn't know how to tell the dog to fetch. Even though the dog can fetch, the animal class doesn't know about anything called fetch, whether that's a data member, whether it's a method. It doesn't know, so it's not able to actually call that. So that's just something to keep in mind when you're using polymorphic pointers like this. So the animal class has no fetch member, even though the object itself does. Okay, so our cat isn't really doing anything. And if we look at our output, let's run this. Right, the cat just acts like a mammal, and when the cat speaks, it says hello. And we all know that cats say hello, so we want to have some way to force cat to implement the speak method. And the way we do that is we make a pure virtual function. So we have the virtual keyword, we have the method signature, and then we set that equal to 0. And that tells C++ that this is a pure virtual method because it's a virtual method, but it's assigned to 0. So this would be a pure virtual method. And the key with a pure virtual method is that it has to be overridden by any non-abstract derived class. Meaning if we want to instantiate some child class of this class, we have to implement this method. So think of it as like a abstract method in Java. So now if I compile, well, first off, now that speak is virtual, we can say that we're overriding it here. And again, we don't have to do that, but what's nice is, well, I'll show you that in the next example. So here, we're going to run into a lot of errors because now A is an abstract class now because it has a pure virtual method. So we're going to need to not do any of this stuff right here because we can't instantiate an animal object. And all of this code is no longer usable as well. So in all of these cases, we have an instantiated animal object. So let's comment that code out and let's see how many of the errors that gets rid of. And that's fine, really, because if you think about it, there's not really a case where you would just have a animal, right? That doesn't make sense in the real world. Yes, something is an animal, but if it's an animal, we can be more specific than that. We can say that's a dog, that's a lizard, or something like that. Now I'm also getting the same error for C, which is type cat, because cat is abstract. So what I need to do is go up to cat and implement, and it should tell me that the speak method needs to be implemented in cat. So I can go up there and I will copy the dog method and just change that to cat, and the cat will meow. And if I do that, that should satisfy that warning. And when I run that, notice now the cat meows. It still uses the base class animal methods because it hasn't implemented or overridden any of those. Now where the override method itself is nice is, let's suppose I wanted to say how many times I want that dog to bark. So I'll pass in an integer parameter like this. Here's our parameter. And now when I try to compile this, it'll tell me, oh, something's going on here. That was a bad one to pick because when I did that, first off, I have the override issue, but now I'm not overriding that default method. So let me do that here for move, since that's a nice virtual method that's implemented and it doesn't make my dog abstract. So if I compile this, it's marked override but does not override because the base class method doesn't take any parameters. So I have to have something with a signature that matches something in the base class to indicate that I'm overriding. So if I'm defining my class correctly, then using this override keyword helps me avoid issues where I accidentally change the method signature, but I'm expecting that to override. And so later on I could have a bug because it might call an unexpected method. Okay, so I think once we've done that, we should be able to compile and run this. So I could do the same thing as I did above with animal references. So if I wanted to do something like animal reference a cref, make that equal to C, I'll use a cref here. So this is an animal reference to a cat object. And when I run that, you see we get the same results that we would get with cat. And the same rules as far as virtual methods and so forth apply there. So if we did that, it might be better to do that with dog. Or actually, let's go ahead and implement, we'll overload another method in cat. So since that one's not virtual, that's not super interesting. We'll go ahead and do move. I don't know how a cat moves. So let's see. And we remember, well, yeah, we are going to override this. So it'll just say later. So let's compile this and run. And now notice the cat does have a method. And with the reference, we get the cat move method because the rules follow the same as having an animal pointer. The same rules apply with an animal reference as far as how or which method gets called. So this is a quick overview of inheritance and virtual methods. And then polymorphism would be using the animal reference or pointer to refer to dog or cat methods, right? The animal type doesn't care if it's pointing to a cat or a dog because it'll allow you access to all the members of animal that exist in cat and dog. So we'll do another example of this in a different video that is a little closer to more of a real world type example, but I think this should give you at least an idea of how the mechanics of inheritance, polymorphism, and then virtual functions work.